In the spring of 2026, a simulated 5-week air campaign against Iran modeled the brutal reality of a modern, high-intensity conflict. Over 35 days, American planes and ships were tasked with striking more than 13,000 individual targets. That rate of munitions consumption drains stockpiles instantly. Current military procurement and supply chain structures cannot sustain that kind of burn rate. The simulation made it clear: surviving a sustained conflict requires mass, payload capacity, and deep magazines, not strictly the possession of exotic technology. For 2 decades, the United States military's primary solution for operating in contested airspace has been 5th-generation stealth fighters, like the F-22 and F-35. Looking at the underside of an F-35 reveals the physical compromise of remaining undetected. Weapons must be stored entirely inside. These internal bays place a hard ceiling on the total number of munitions a jet can carry, and how large future missiles can be. To offset this limitation, the Air Force planned to build 750 F-22 Raptors, but massive costs forced production cuts down to just 187 jets. Relying entirely on a small fleet of stealth fighters creates a severe tactical bottleneck, depriving the military of the raw capacity required to win a sustained war. To solve this payload deficit, the Air Force rapidly doubled its procurement orders for an aircraft based on a silhouette that first flew in 1972. By selecting an existing airframe, defense planners bypassed a 15-year development cycle and immediately tapped into active supply chains built for foreign export models. The F-15EX Eagle II shares its exterior with older jets, but the internal architecture was gutted. The mechanical linkages were replaced with a digital fly-by-wire system and modern mission computers. Because it lacks stealth, the EX survives using ePAWAS, an advanced electronic warfare suite designed to actively detect, locate, and disrupt enemy radar systems. The Eagle II intentionally trades invisibility for massive power generation and active electronic jamming. 2 engines produce nearly 30,000 pounds of thrust each, allowing the aircraft to haul an equivalent combat payload across as many as 25 hardpoints. As this scale comparison shows, this external configuration allows the EX to carry up to 16 air-to-air missiles, or oversized next-generation hypersonic weapons that stealth jets cannot fit. A non-stealthy jet can safely carry this massive arsenal because modern data links mean it never has to see the target itself. This diagram illustrates the networked fleet concept. An F-35 slips behind enemy lines to act as the invisible eyes, instantly transmitting targeting data backwards. The F-15EX receives this data and acts as a long-range squire, launching a wall of missiles from hundreds of miles away. The F-15EX serves as a limitless, off-board magazine, providing the raw firepower that stealth fighters cannot carry internally. This strategy extends globally. Allied nations are investing billions in upgraded 4th-generation fighters for air policing and precision strikes. Operating these aircraft provides logistical practicality. Allied forces can share maintenance expertise and utilize existing supply chains at a fraction of the operating cost of 5th-generation fleets. Yet, returning to the hypothetical Iran campaign reveals a sobering lesson. Despite its capabilities, the brand new F-15EX sat out the war entirely. Due to production delays, only 27 of these jets existed by April 2026. You cannot build an air campaign around a fleet too small to sustain rotations and absorb losses. The greatest combat aircraft on paper is tactically useless if procurement pipelines cannot deliver it in the numbers required to actually fight. The F-15 was originally designed as a brute force airframe to counter Soviet threats like the MiG-25. That design possessed so much physical room for growth that it successfully absorbed 5 decades of technological advancement. Victory in future conflicts will require the smartest mix of capabilities, rather than relying exclusively on the most secret, cutting-edge technology. When the first night of the war is over, military planners must decide what matters more: invisibility or a reliable wall of missiles under the wings. In modern military aviation, adaptability and mass prove that sometimes evolution beats revolution.